I looked at Stockwell Bus Garage for this project. Stockwell Bus Garage was opened in 1952 after the transition from trams. Post-war shortages of steel were a large factor for using concrete. I chose to study this building because despite its quiet presence in London, it is an iconic piece of history. When it was built, it was the largest column-free area under one roof. The portal frame structure consists of 9 barrel vaults spanning 120 metres. The load path diagram shows the concrete roof slabs are supported by a series of frames spanning the width of the structure, which in turn directly transfer the load to the foundations. Added weight due to roof servicing was accounted for in the calculations. Despite London's low risk of snow loading, I have incorporated this parameter for worst case loading. From my wind loading calculations, it is worth noting that the largest peak velocity pressure comes from the west at 0.56 kilonewtons per metre squared. The building's height is significantly smaller than its breadth. Therefore, lateral loading is not a significant issue. The intersection of 10 ribs with 9 smaller ribs prevents torsional effects and gives the structure superb lateral stability. However, the large openings for buses around the garage could be problematic for uplift, where wind flow can push the roof upwards. Here are factored load combinations. It is highly unlikely that snow loading and maintenance will occur simultaneously, therefore only snow loading was used. In my calculations, I considered the concrete ribs as an arched beam supported by 2 separate columns either side. I decided to size the edge beams along the length of the garage according to EC2 specifications. They do not carry substantial vertical loads, they are more significant for lateral stability. No compression reinforcement was required. My calculations concluded that the beam would require 532 diameter steel bars for tension reinforcement. EC2 calculations showed that the beam required 3 8mm stirrups spaced at 390mm. The real designs show it as an H-beam as opposed to a standard rebar beam. The orientation of the flange beam means it has greater lateral strength. The columns are subject to great axial load, therefore a large cross-section is expected. Column is stocky, so it needs little steel reinforcement, but this is also because I did not include moments due to wind loading. The columns require 8mm bursting links spaced at 400mm. In reality, the ribs have far more steel reinforcement, thus they will have greater lateral strength, and I expect it to use far less concrete. Today, it would be possible to use lightweight aggregates in the concrete. The lighter roof would massively reduce dead loads, making savings in foundations and reinforcement. This would significantly reduce the structure's embodied carbon footprint.